Part 2, this is for questions 7 to 10. Question 7 is coming from functions. The function f is defined by f of x is equal to 2 minus 5 over x plus 2 for x greater than negative 2. So they are using x greater than negative 2 because if you get this x plus 2 and you equate it to 0, then x is going to be equal to negative 2. Now, when you have a 0 here, 5 over 0, it becomes undefined. Okay, so that means at this line here, the curve doesn't cross it. Okay, in other words, it is what we call an asymptote. An asymptote is a line that is not crossed by the curve. So x cannot be equal to negative 2 for such a function. So either maybe you choose the right side of this negative 2 or the left side. So for this case, they chose what? The negative sign, such that this graph here can have an inverse, because the function can only have an inverse if it is 1 to 1. See that? Otherwise, the domain here would have been x not equal to negative 2. Then this would mean that we are considering all values of x except what? Negative 2. All right, now let's continue. They are saying that state the range of f. Now you can see from here that whichever value of x you're going to put here, of course, most of them are going to be positive. Like, for example, if I put a negative 1 here, I'm going to have a 1. You see? So 5 over this 1 here, you'll get a positive thing here. So again, whichever value you're going to put here that is greater than this, you're going to get a positive thing here. Now, that positive number you are getting here, you are subtracting it from 2. That means whatever is coming out of that, the value of f of x is going to be smaller than what? 2, because of this what? Subtraction. So this simply means that f of x here is going to be less than 2. So this would be the range, as simple as that. And remember, when we are writing the range, we write it in terms of the function, then the domain is written in terms of the independent variable, and for this case it is x. Then part B, obtain an expression for the inverse and state the domain of the inverse. If I have the inverse here, which is equal to y, then I can take the f this side. I will have x is equal to f of y. Then from there, where there is x in f of x, I'll put what? The y. You see that? So that means 2 minus 5 over y plus 2 will be the substituted expression. Now, we need to make y the subject of the formula. This part here is negative, so first take it this side to become a positive. So we shall have 5 out of y plus 2, which is equal to 2. Take the x this side, minus x. Then we can cross multiply. When we cross multiply, of course, we are going to divide, so I'll just have 2 over, then 2 minus x. Then this one is equal to y plus 2. So meaning y shall be equal to 5 out of 2 minus x, then minus 2. So this simply implies that our inverse is going to be 5 minus 2 minus x, then minus 2. Okay, that will be that. Alternatively, this inverse can be, get this one times this. You can have 5 minus 2 into 2 minus x, and the whole thing is out of 2 minus x. Then simplified, we can have, this is a 4, so 5 minus 4 is a 1. Then a negative 2 times negative x, that will be 2x. So 1 plus 2x, then out of 2 minus x. So either way, you get the answer. So it is either this one here or this one here. Now, they told us to also state the domain. Now, if I have a function, if I have a set of values here of x, and then I have a set of output So if f acts on the x here, the result is going to be f of x. Okay. Now, the set of values that goes into the function is what we call the domain of that function. So this one is going to be the domain of f. And then here, what comes out, the set of outputs is always the range of that function. Okay. So the function which undoes what a function has done is what we call the inverse function. Are we there? Now remember, I've said that the domain is the set of values we put in a function. So if this is the inverse, this means what is here is what we are going to put in the function. So it becomes its domain. And then what comes out is its range. Are we there? So this simply means that here we shall have domain of inverse, and then this will be the range of the inverse. So from here, the domain of the inverse is the same as range of f. You can see domain here, the same as the range there. Now, what is the range of f? Range of f is f of x less than what? 2. But when we are writing the domain, we write it in terms of the independent variable. We write it in terms of what? The x. So this simply implies that domain of f inverse is going to be, now we remove the f of x, we remain with x, then we say less than what? 2. Here we have f of x. Okay, so this one is a range, so it is written in terms of the function. Now the domain has to be written in terms of x, so this has to be our answer here. The function g is defined by g of x, which is equal to x plus 3 for x greater than 0. Obtain an expression for fg of x, giving you answer in this format here, where a, b, c, and d are integers. Now fg of x, people always do this mistake here. They say this is the same as get f of x then times g of x. No, this is different. This is a composite function. We are putting a function into another. Okay, it's like singing a song. They say, they always ask, who composed this song? A song, in a song, you are going to have an intro, you are going to have the chorus, you are going to have the verses. All of those put together, they give you the song. They are composed into one thing. You see that? So with our f of x, which was given as 2 minus 5 over x plus 2, 5 over x plus 2, then fg of x shall be equal to 2 minus 5 out of, where there is x, I'm going to put g of x, then plus 2. Okay, you see this one is f of x, so where there is f of x, you are putting what? The whole of g of x. All right, now we simplify this one here to be 2 minus 5 out of, this is x plus 2. Actually, it's not a 2, it's a 3. X plus 3, then plus the 2. So this is 2 minus 5 out of x plus 5. This one is over 1. The LCM is going to be x plus what? 5. So divide by 1, you get x plus 5, then times 2. That's why I always say, just get this times that. See that? And so we have 2 into x plus 5. Then this, divide by that, you get 1, then times this. So you have the 5 there. And then we shall have 2x here, then plus 10 when we open the brackets, plus 5 out of x plus what? 5. Then at the end of it all, we are going to get 2x, then plus 15 out of x plus 5. This is our answer. Now, when you look here, that means our a here, our a is going to be 2, our b is going to be 15, our c is going to be 1, coefficient of x there, and then d will be equal to 5. Question 8. A progression has the first term a and the second term a squared over a plus 2, where a is a positive constant. Part A. For the case where the progression is geometric and the sum to infinity is 264, find the value of a. Now, sum to infinity is this one here. So we have a, the first term, which is a. Then the second term is AR, which is equal to a squared out of a plus 2. You see? So meaning, for me to get r, it will be this a squared out of a plus 2. Then we divide it by what? By a. So that is the same as saying times 1 over a. Are we there? Then this one will reduce this one to a. So meaning what we are going to get here, r is going to be equal to a out of a plus 2. Now, sum to infinity, we know it is given by a out of 1 minus r. Okay? Now, this is a out of 1 minus r is a out of a plus 2. Also, then this one we shall equate it to 264, which we were given here. Now we need to simplify this one here. Okay. So when we cross multiply, we can have a, which is equal to 264, then into 1 minus a out of a plus 2. You see that? Then from there, if we can open the brackets, that is 264, then minus 264a out of a plus 2. Now everywhere, I'm going to multiply by a plus 2 to eliminate this denominator here. Okay? So what do we have here? We shall have a, then times a plus 2, which is equal to 264 times a plus 2. Remember, everything that is in here has to multiply this, okay? Then next, this one will multiply and that one goes away, not so? And then we have minus 264 of a. So opening the brackets, this will be a squared plus 2a, which is equal to 264 of a, then plus 264 times 2, 26 times 2, that one gives us 52. Then 4 times 2, that will give us 8. Then minus 264 of a. That means this one is going to cancel that. I can bring this one this side so that I get a quadratic equation in terms of a. So we shall have a squared, then plus 2a minus 528, which is equal to 0. This is a quadratic equation that can be solved by a calculator right away. I'll go to mod, then equation is option 5, then quadratic is 3. The coefficient of a squared is 1. The coefficient of a is 2. Then the constant part is negative 528. Okay, then we get 22 and negative 24. So I'll say a is equal to negative 24, and then a is also equal to 22. I've left space here because I need to show the examiner the attempt to solve this quadratic equation. You don't just write this and then you will lose a mark. So what do? Bring this one here and also bring this one here to give us the factors from which these roots come. Okay, so this one will be a plus 24, and then the other one will be a minus 22, which is equal to 0. By doing so, you have cheated the examiner. You have shown the attempt to solve the quadratic equation using factorization method. You see that? So they are saying for the case where the progression is geometric and the sum to infinity is that, find the value of a. And they said a here is a positive what? Constant. So if it's a positive constant, this simply implies that our a is going to be equal to 22. That is that. For the case where the progression is arithmetic, that is part B, and a is equal to 6, determine the least value of n required for the sum of the first n terms to be less than negative 480. Now, we have the first term is a. Then the second term, which is a plus d, is going to be a squared, okay? A squared, then out of the a plus 2. Isn't that what they gave us? I believe so. Yes. Now, you look at the question, the way it was set. This is the main stem of the question. Then there is part A under it. Then here, part B, you see? So that means also here, the first term is A, and the second term is a squared over what? Over a plus 2. So A is 6. So D is going to be equal to 6 squared out of, this is 6, then plus 2. Then from there, we subtract the A when it crosses, which is the 6. So altogether, what is our D? 6 squared, then we divide by 6 plus 2, that is 8, then minus 6, that will be negative 3 over 2, negative 3 out of 2. Now, sum of the first n terms of an arithmetic progression is n over 2 into 2a, then plus n minus 1 d. Not so. So they said this one here has to be less than what? 480. So we shall have n over 2, then into 2 times the 6, then plus n minus 1. Our d is negative 3 over 2. Then this one has to be less than negative 480. Okay? Then when we multiply, we can actually multiply all through by 4. Okay, let me not take you so fast. This one here multiplies here, that one goes, so we shall have 6n, not so? Then minus, this is minus 3 over 2 times this one here. You will have a negative 3 over 4 of n. Now times this n, you'll get negative 3 over 4 n squared. Then negative 3 over 4 n times the negative 1 that is inside here. That one will give us a positive. It will give us a positive 3n over 4. So less than negative 480. Now I'll multiply all through by the 4. You see that? Such that I can eliminate the denominator. So this will be 24 of n, then minus, there has to be an n squared here. Pardon me here. Okay, then minus, this will be 3n squared, then plus 3n, then is less than this one here times 4, then that 192, 192, then 0. So I can take this one, this other side, or let's say we take this on this side. So we shall have negative 3n squared. 24 plus 3, isn't that a 27? So we shall have a 27 of n, then plus 1920, then less than 1, 0. Now we divide all through by negative 3. Divide all through by negative 3. So that means here we'll have n squared, then here minus 9n, not so? Minus 9n. First of all, here when you divide through by 3, you'll get 16, then with a 0, then times this 4, then you get what? 640. Yes, so that means this one we shall get minus 640, then less than. Now that one is going to be greater than 0, because whenever you divide an inequality by a negative, or you multiply all through by a negative, the sign has to change. So it will be greater than. Okay. Now, this is a quadratic equation. We can factorize it using the calculator. Mod equation is 5, then 3. We have the coefficient of n squared is 1. The coefficient of n is negative 9. and then the constant part is negative 640. Now here we get we get this one here. So this one was not factorizable. Okay, so since it wasn't factorizable, you need to show the attempt to solve. Now you show the examiner that you solved this one using the quadratic formula. Okay, so our n is going to be equal to minus b, that is minus 9, then plus or minus to the root of b squared minus 4, then sc, our a is 1, c is negative 640, like that, then out of 2a. Okay, now after substituting here, you have shown the examiner. Okay, so what you get is n is equal to what do we get inside here? So we need to write something that is exact. I want to deal with exact, so I can have plus. What do we get inside here? 81 minus 4 into negative 640. That is 2641. So root of 2641 out of 2. Okay, then we also have n, which is equal to 9 minus root of 2641 out of what? 2. Now, since the coefficient of n squared here is a 1, then this one is going to give us a U-shaped curve. Okay, and then the two critical values we are having are these ones here. So of course this one is smaller, so I'll put the 9 minus square root of 2641, then out of 2, then this one is 9, then plus the square root of 2641 out of what? 2. Now this is positive. Whichever value of x that is greater than this, the value of y is above this x-axis. You see that? And then also this other side, when you go this way, the value of y is above x-axis. It continues up here, so meaning that even this one is positive, but in between these two it is negative. It is below the x-axis. You see? Now right from here, our answers can be n less than this and n greater than that. Okay, for the positive, because here we have greater than what? 0. Okay, so we can have n less than the smaller value, 9 minus root of 2641 over 2, and then n is greater than the bigger one, 9 plus root of 2641 over 2. Now they told us to find the least value of n required for this. So least, that means we have to look at where there is greater than. Okay, so it has to be greater than this one here. So first of all, n here is greater than the value that is here. When we go back to our calculator, we have this 30.195 and the rest of that. So 30.195 and the rest that comes. So that means our n is going to be equal to 31. Okay, the least from here, if the smallest has to be 30.19 and whatever. And you know that when it comes to the terms, they have to be whole numbers. So the next integer in line is 31. So that has to be our answer. Question 9. A curve which passes through 0 and 3 has the equation y is equal to f of x. It is given that the f prime of x is this one here. Find the equation of the curve. We just need to integrate here. So y, because they differentiated, that means we need to integrate to go back. These two, the differentiation and integration, they are reverses of each other. So I will write my f of x, which is equal to the integral of f prime. So that will be the integral of 1 minus 2, then into x minus 1 then power negative 3 using the rules of indices, okay? When this one goes up, the power becomes a negative. And then when you integrate, you increase the power by 1 and you divide by the new power. So this one becomes x, and then here 2 into x minus 1. When you increase the power by 1, this one will become negative 2. You divide by negative 2 here, but you will multiply by the derivative of what is inside here, because this one came from differentiation using the chain rule, okay? So times times the derivative of what is inside here, which is a 1. Then we shall put an arbitrary constant c, because we don't know the derivative, the constant that disappeared when they differentiated. So our f of x, therefore, is going to be equal to x. This one will cancel this. It becomes a plus, not so. And then this one, I can take it down. And then I can have 1 out of x minus 1 squared, then plus the c. Now, if a point lies on the curve, that means its coordinates must satisfy the equation of that curve. So I will use this one here as 0, 3. That means x is equal to 0, not so? So we shall have 3 is equal to 0, then plus 1 over. This will be negative 1 squared, then plus c. So this one will be a 1, then when it crosses, it becomes a negative. So 3 minus 1 is equal to c, and then our c becomes a 2. So meaning that f of x is now going to be x, then plus 1 out of x minus 1, then squared, and then you add a 2 here. So that is going to be our answer here. The tangent to the curve at 0, 3 intersects the curve again at another point P, and they are saying show that the x-coordinate of P satisfies the equation, this one here. After finding the equation of the tangent at this point here, then we solve that equation simultaneously with the equation of the curve which we have gotten here, okay? Then from there we can get the equation for the solution of those two where they meet, okay? Now, let's find the equation of the tangent at 0, 3. Remember, to find the equation of a straight line, you need to get the gradient and at least one point through which a line passes. So what is the gradient of the tangent, which is given by dy dx? Our dy dx, remember, is this one here. It was already given 1 minus 2, 1, then minus 2 out of x minus 1 what? Cubed. So that means where there is x, I'm going to put what? I'm going to put a 0. So that will be negative 1 actually. Then we have cubed there. All the power of a negative is always a negative. So this one will be, what shall we have here? A plus. So because this one's a negative and this one is a negative, you get a plus. So 1 plus 2, that one gives us a 3, not so? So meaning equation of tangent, equation of the tangent at 0, 3. Now already x is 0. So remember we have, a y is equal to mx plus c. So if I'm putting this one in here, this one will be a 3, then a 0 here, then plus c. So that means this is the y-intercept already. So that c is a 3. So I will put y is equal to the gradient, which is 3x, then plus what? The 3 here. Now, solving simultaneously with the equation of the curve. So that means if you got the other equation of the curve wrong, there is no way you are going to get this one right, okay? So solving simultaneously with the equation of the curve. The equation of the curve, we have seen here, it is x, then plus 1 over x minus 1 squared, then plus 2. So I'll write y is equal to x then plus 1 over x minus 1 squared then plus 2. So I'll equate the two because all of them are equal to y when I'm solving simultaneously. So we shall have 3x then plus 3. This one is equal to x then plus 1 over x minus 1 squared then plus 2. Now I'm going to first bring these two this way to simplify. So we shall have 3x plus 3, then minus x minus 2. This one will give us 1 over x minus 1 squared. And this one will give us 3x minus x, that is 2x. Then 3 minus 2, that will be positive 1, not so. Then is equal to x minus 1 squared. And then when we cross multiply, this will be 2x plus 1, then times x minus 1 squared, which is equal to 1. Now when we bring this on this side, you are going to have the 2x plus 1, then times x minus 1 squared minus 1, then is equal to 0. So this equation we have gotten here is the one we are supposed to solve to give us the x coordinate of the point of intersection. You see that? So that is the one, and they told us to prove it. So that is it. Then part C, verify that x over 3 satisfies the equation and hence find the y coordinate. Now, if we have 2 times 3 over 2, then plus 1, I'm substituting here, okay? Then times, this is 3 over 2 minus 1, then we square that, minus 1, what do we get? So first of all, 1.5 times 2, that is a 3, then plus 1, that will be a 4. Then times, this one here is going to be 1.5, not so, I mean 0.5 from here. 1.5 minus 1, you get 0.5, which is a half. Then when you square it, it is going to be a quarter, then minus 1. So you can see that this one is 1, then minus 1, which is equal to what? 0. And that is what we are having here. So verified. Hence find the y coordinate. So to find the y coordinate for x, which is equal to 3 over 2, you can go up here and you use any of these equations, either this one or this one here, because those are the ones that are intersecting. But I will use the one of the line, which is very easy. So y will then be equal to 3, then x is 3 over 2, and then plus the 3. So this one here is going to be what? 9 over 2, 9 over 2, then plus 3. So 2 times 6, I mean times 3, that is a 6, then plus 9, that is a 15. So that means the y coordinate of P is going to be equal to 15 over 2, which you can write as 7.5, 7.5, whatever. And that is that. Question 10, the diagram shows points A and B lying on the curve with the equation, this one here. Find the coordinates of the maximum point of the curve. Now, this one has been increasing. That means there is a gradient, okay? There's a change in y and there's a change in x. Now, at this point here, it turns off, okay? So before it turns off, it stops momentarily, just like you can throw something in the air. That means at this point here, there is no change in y and no change in x. So that's why we always say that for stationary points, then dy dx is equal to what? 0. Now, let us differentiate. So if y is equal to this one here, then dy dx is going to be equal to, this will be 9, then minus, drop that power, then reduce it by 1. This one is 1.5 minus 1, you get 0.5, which is a half. Then enter inside and you differentiate this one here using the chain rule. So that will be 2. And then of course this one will go away. That means we shall have 9 then minus 3 into 2x plus 1, that is the dy dx, the power of a half. Okay, then we equate this one to what? To 0. And then from there I can have a 9, then take this one this side, 2x plus 1, then power half. Now I can divide all through by 3. That means here I can have 3, and then here 2x plus a half, 1 to the power of a half. And then after here, I square both sides. Remember, I'm looking for x. So square both sides, we shall have a 9 here. And then here you'll have 2x plus 1. Okay? Okay, so let me maybe first write it like this. I put a 3 here, then I say square, and also here, square this. So when you do so, you get a 9 here, then this one is going to cancel with that, and then we get 2x plus 1. So take the 1 here, 9 minus 1, that is 8. Then we shall divide all through by 2, okay, to get the value of x. So meaning x is going to be equal to what? To 4. What do they want? Coordinates of the stationary point. And if x is equal to 4, then what is y? So y will be equal to, you substitute in the equation of the curve, that is 9x, then minus, this is 2 times 4, then plus 1, and then we get 3 over 2. Now, 2x plus 1, we have seen it is a 9, okay? Or you want to say 8, then plus 1, 9. Then square root of 9 is 3, right? Then 3 cubed is 27. And by the way, I don't know why I never substituted the x here. So there is something wrong here. I'm supposed to send 9, then times the 4. So this one is going to be 36, then minus 27. And this one gives us a what? A 9. So meaning the coordinates of the stationary point will be 4 and then 9. That is that. Then part B, verify that the line AB is the normal to the curve at A. Remember, when we are finding the equation of a straight line, we need the gradient and then the one of the points through which a line passes, right? Now I'm assuming the curve looks like this. So suppose I put a tangent here. The line which is perpendicular to the tangent is what we call the normal. Okay, this is the normal, this is the curve, this is the tangent. So they said at A, when we go back to A, here, this is 3 over 2, and then this is 11 over 2, okay? So at A here, which is 3 over 2, and then 11 over 2, dy dx, which happens to be the gradient of the tangent, will now be, what is our dy dx? Our dy dx is here, this whole thing here, okay? So I'll have 9 minus 3 into 2x plus 1, then power a half. So x is 3 over 2, so times 3 over 2, then plus 1 power a half. This one will go. What shall we have? 3 plus 1, that is a 4. Then 4 power a half, that would be a 2. Then 3 times 2, that one becomes a 6. So 9 minus 6, that one gives us a 3. Okay, now this is gradient of the tangent, and these two are perpendicular, and we know that the product of two gradients, the product of two gradients of two lines that are perpendicular is always equal to -1. So that means gradient of the tangent, normal, gradient of normal is going to be equal to -1. If this is the M2, then -1 out of M1, which M1 is this 3 here, the gradient of the tangent. Okay, now using y minus y1, which is equal to m into x minus x1. So our y1 is this 11 over 2. 11 over 2 then is equal to m is negative a third, and then we have 3 over 2. No, pardon me, here we have x then minus 3 over 2. Then when we open the brackets, y will be equal to negative a third of x, then plus, when you multiply here, we shall get a half, not so, because if you have that, this one will go, and a negative multiplied, we get a positive. So that is what we are having here. Then plus 11 out of 2, like we take this on this side. So meaning the equation of the normal at a is going to be negative a third of x. This will be 12 divided by 2, that's a 6. So plus 6, that is that. Then part C, find the area of the shaded region. So area of the shaded region, you can see here, area of the shaded region. Now, the normal is this line AB the normal? Yes, line AB is the normal. So what we are going to do here, we need to get area under this curve. Okay, it is going to be the whole of that, then minus this area under this line here. You see that area under this line here, or we can say area of this trapezium. You see, so we are going to get the one which is above the other minus the one that is below, as simple as that. So we shall have shaded area, which is equal to the integral. The x coordinates are 3 over 2 and then 15 over 2, not so. 3 over 2 and then 15 over 2. Then we have the equation of the curve, 9x, then minus, we have here 3x, actually it is 2x plus 1, it is 2x here, plus 1 to the power of 3 over 2. Then we subtract the equation of this line, okay? The equation of this line here, which we have here as negative a third of x, then plus 6, okay? But be careful, this thing is like that altogether. And then after that, we integrate with respect to x. Now, first I'm going to simplify what I'm having inside here, okay? Now, 9x minus, this one will actually be plus, okay? So plus a third of x. This one will be 9 times 3, that is 27 plus 1, 28. So that means I will have 28, okay? 28 of x out of 3. Then minus, this is 2x plus 1 power 3 over 2, and then minus 6 here when you open the brackets. Then we integrate with respect to x. Now we begin. When we are starting the process of integration, we take away the integral sign. Now we are putting the square brackets. You integrate, increase the power by 1, divide by the new power, so you have 28 of x squared over 3, then times the 2. So this 2 reduces this one to a 14. So that means we shall have 14x squared out of 3. Then minus, here we shall have 2x plus 1. Then add a 1 here. 1.5 plus 1, that is 2.5, which is 5 over 2. Then you divide by the new power, which is 5 over 2. But you multiply by the derivative of what is coming from here. Since in the differentiation, they use the chain rule, we multiply all through. Now in integration, we divide. So this will be a 2 here. then minus 6x. Okay, then we put the limits. We have 15 over 2 and then 3 over 2. Then we continue to simplify this. So this one will go into this one here. How many times? That one will give us 14. So we have 14 out of 3 of x squared, then minus, this is 2x plus 1 out of, this will be 5 because this one goes, and then this one is to the power of 5 over 2, then minus the 6x, and then if you have 15 here over 2 and then 3 over 2, now putting the limits will give us 14 over 3, then 15 over 2 squared minus, then we have 2 times 15 over 2, which will give you a 15, then plus 1, that will be a 16. So this 16 here, I'm powering it. Oh, there is a mistake here. The 2 is only on this one here. Okay, let me write it again. That is 15 over 2, then plus 1, and then to the power of 5 over 2, then out of the 5, then minus 6 times the 15 over 2. Then after that, to go to the lower limit, I put a minus, so this will be 14 over 3. Then here, wherever there is 15 over 2, I put 3 over 2. Okay, so then minus, this will be 2 and 3 over 2. That one will give us a 3 plus 1, that is a 4. Then we power it with 5 over 2, and then we divide by 5, then minus 6, then times 3 over 2, like that. And then now we can put the whole of this in the calculator, but first I will put this one here, then this one here. 14 out of 3, then times, this is 15, let me just write 7.5, okay? Then minus, up here, we are going to have, this will be 15 plus 1, that is 16, then to the power of 2.5. Then what else? Down here, we are having a 5, right? Yes, then minus, this will be 6 times 7.5. So this one gives us 127 over 10. 127 out of 10, which is 12.7. Then minus, what do we get here? Now I will come to this, and wherever there is a 7.5, I'm going to put what? 1.5, Then here, I'll need to simplify what is in brackets here. So 2 times 1.5, that is the 3 plus 1. That one will give us a 4. Then power the 2.5 over 5. And then this will continue. 6 then times 1.5. And our answer becomes negative 49 over 10. That means this 2 will give us a plus. So our answer is therefore going to be 127 plus the 49 over 10, right? 127 plus 49, that is 176. So when you divide that by 10, your answer becomes 17.6. And that is that. So this has been it for this paper. Thank you so much for watching. May God bless you. If you find the content very helpful, kindly like, share, and even subscribe. See you in the next videos.